Well, good morning, ladies and gentlemen. This is your well-rounded math teacher, Mr. Picard, and we're in Unit 2, working on Notes Video 4, Special Functions. Our learning targets, we can depict from a graph the type of function, including absolute value, piecewise, and step functions. And there's a few other ones, and we're going to talk about those now. One of the essential understandings from this chapter is students can understand or can determine between linear, step, absolute value, constant, and identity functions by looking at their data, the function, or the graph itself. So those are the things we're going to be looking at. Getting into our first graph here, we're going to look at a real-world problem. And the real-world problem is this. How much it costs to mail letters, and it goes by their weights for the U.S. mail system. It says, is this function right here a linear function? In other words, if you were going to graph these, would it form a line here? Now, the way you got to look at it is this. Let's graph this. And I'm going to put weight right here. There's 1 ounce, there's 2 ounces, there's 3 ounces. 1, 2, and 3 ounces. And just with the numbers they have over there, 39 cents, 63 cents, and up here we'll go with 87 cents. Now the first thing is it a linear equation? Well, 1 ounce costs 39 cents. So at 1, it's going to be 39 cents. How much does a half ounce letter cost to mail out? Well, it's still going to be 39 cents. Anything 1 ounce or less is 39 cents. So 39 cents here, here, all the way over. If it's 0 ounces, in other words, you're not sending a letter, it's going to be 0. Anyway, the next one, if it's 2 ounces, it's 63 right here. And it's going to be 63 cents until you get that back down to 1. Now the open circle right here, that's its starting point. We're at, if you do a dotted line up here, it's all at 1. Anything over 1, 1.001 ounces is going to be 63 cents. So it jumps up to the next one and goes across. So anything over 2, that's 2 right there, 2 ounces, but anything over 2 is going to be 87 cents, all the way up to 3. Now this particular function right here is what we call a step function. Is it a linear equation or linear function? No. Why not? Well, this graph here, there's like 1, 2, 3, and there'd be infinitely many pieces here depending on how many ounces there are. So it's not just a line like we have over here. What's the cost to mail 1.5 ounce letter? Well, 1.5 would be right here. Going up here, it would be 63 cents. 63 cents. It's over 1 but under 2, so it's the cost of a 2 ounce letter. So this is a real world look at a step function. Here's another step function, and we're talking about step function, often referred to as the greatest integer function. The symbol where there's 2 brackets like that means greatest integer, less than or equal to. So a couple of examples here. The greatest integer of 7.3, well, is 7. Basically, you take off the 0.3. If it's positive, if it's negative now, like this one, negative 2.4, the greatest integer less than this would be negative 3. So there's your greatest integer function. So basically, anything between 7 and 7.99 is going to be 7 on the graph. So like right here, if I circle this, all these numbers are between 1 and 2, and if you notice, they're at a height of 1. This is the greatest integer step function. It's an example of a step function. Let's pick another one here. Between 2 and 3. Anything between 2 and 3 is equal to 2. That's your f of x part, or y. F of x and y are basically the same thing. So I go over to 1, 2 right here. I'm jumping up, and this is my function. Now, one thing you got to notice again, they talk about it here. If it's closed in, that means it's part of the function. If it's open, that means you're skipping to the next part up here to where it's actually closed in again. So an example of a step function is where you have, it looks like actual steps on the graph. Not a linear function, but a step function. Another real world one here as far as step functions go. No leaks. RS Plumbing Company charges $60 per hour or any fraction thereof for labor. Move this up here. Yeah, that's right. I'll get that out of there. Actually, let's move this down. So this is our x, and that's C of x, your cost. Between 0 and 1 hour, it's going to be $60. So if I was graphing that, I'm going to put a little circle here at where 0 would be on the line. So 0 hours. It's circled at 60, but that means it doesn't charge 60. But anything over 0 hours up to 1 hour is going to be $60. Jumping up to 120 now, I'm going to put an opening there. 1 hour does not cost 120, but 1.1 hours would. Anything up to 2. Between 2 and 3 hours, actually, let me list this over here. X, this is basically, if you read this backwards, x is greater than 1, and x, I'm not reading it backwards now, is less than 2. That's going to be $120. And we just graph that. Between 2 and 3 hours, I'll put my x in there. It's less than or equal to, it could be 3 hours, and it's still going to cost $180. But x is greater than 2, or 2 is less than x. That's going to jump up to 180. So open end means it doesn't count, but anything above that would count, and circled in does count. And we'll go one more. Between 3 and 4 hours, it's going to be $240. So jumping up here and over. Very good. So turning our paper over. Let's just look at, first of all, the constant function. This is a common function. You'll see this once in a while. Now remembering that f of x is the same thing if you want to replace it with y. This is no different than y equals 3. F of x equals 3. This is a constant function because the only thing it's equal to over here is a number. They call it a constant function because a number by itself is a constant. A different one we could graph, how about if we had f of x equals -2. Now, being there's no variable over there, once again, this is what we call a constant function. It's going to be just like this, a horizontal line. If you count it out, -1, -2, there's where it crosses. There is no x, so your slope is 0, so it's just a horizontal line like this. Horizontal line, or constant function. So whenever you see a horizontal line, you got to think constant function. There is no x. The slope is 0. Identity function is not the same as a constant function. Identity function says this, f of x equals x. A better way to look at it is y equals x. Remembering that f of x is the same thing as y. Identity function means this, if you set up a table, x and y, if I plug in 2 for x, that means y also has to equal 2. So when I'm looking at this, When x is 0, y is 0. 1, 1, 2, 2. That's why they call it the identity function. X is the same thing as y. So when I look at this, y equals x or f of x equals x, when you think of slope-intercept form, y equals mx plus b, well, really there is no b here unless you want to say it's 0. So it goes through the origin. As we can see right here, it goes through the origin. And my slope, well, it's just 1x, so up 1 over 1. And all these points, 1, 1, 2, 2, 3, 3. The x is the same as the y. This is an example of the identity function, which we will be using in the future. Okay. Oh. We got to look at one thing first here, and that is the absolute value function right here. Next thing in your notes. How do you recognize that it's an absolute value function? We see an absolute value symbol. And it doesn't matter if it's x, 5x, x plus 2 in there. As soon as you see absolute value, you think it's an absolute value function. Whenever you're going to graph an absolute value function, your graph is going to look like a V, just like this. This little point down here at the bottom of the V is called our vertex. And I guess the best thing to do when you see absolute value is to set up a table just like they have here. An XY table or X f of x table, whatever you want to call it, f of x or y, and graph some points and find this vertex, the bottom of it, this V. If I plug in -3 here first, which they give us, -3, they go -3 all the way to +3. With plugging in those numbers, if you're going to graph an absolute value function, you should be able to find the bottom of your V, the graph of your absolute value. The absolute value of -3 is +3. 1, 2, -3, 1, 2, you can see my point is right there. The absolute value of -2, well, is +2. That's this point. -1, 1, this point. When I plug in 0, the absolute value is 0 right here. And when I plug in 1, the absolute value of 1 is a 1. Some people say it's -1. They always want to take the opposite of it. But no matter what, when we take the absolute value of a number, we get a positive number. So 1, 1. So you can see you're going down here. You get to the vertex and you go up. And that's more than enough to graph it. Once you find the bottom point, your vertex, when you're graphing absolute value, you can just go ahead and draw on your line. And I'll show you another example of this in a second. But absolute value isn't too bad. Just recognize that when you graph it, you're going to have some kind of a V. And the easiest way to do it is probably set up a table like they have right here. Okay, what's not as easy, what students seem to really struggle with, are the piecewise functions. And the main part of the name is this, piece. You're going to take pieces of different graphs and graph them on the same XY axis. And this is what piecewise function looks like. It'll have f of x equals, and then you'll have this little symbol here. These are the two things that you're going to be graphing, the negative x and x. For this particular one, I don't like it. I'm going to show you a little bit different way of graphing these piecewise functions. And the one I want you to put down for this problem is f of x equals, put a little brace in there, and I'm going to say 2x when if x is less than 0. Now that line represents one thing that we're going to graph in a second here, and we'll get to that in a minute. The other one is negative x plus 1 if x is greater than or equal to 0. Okay, what you got to recognize is this. The things you're actually graphing are the 2x and the negative x plus 1. We're going to do the 2x first. Now remembering that this f of x is the same as y, and we're saying it's equal to this brace and everything in the brace, from this top line I get this, the equation y equals 2x. That's what I have to graph, that linear equation. The x is less than 0 part of it, if x is less than 0 part of it, we'll talk about that in a minute. Let's just graph y equals 2x. Now remembering, this is in slope-intercept form, y equals mx plus b, where m is my slope right here. My y-intercept, there is nothing, so my y-intercept is 0. So I'm going to put a little point right there. My slope is 2, so using rise over run, that's up 2 over 1. Up 2 over 1. Or I can go down 2, back 1. Just putting a line in there. I'll try and get it as straight as possible. There it is. That's f of x right here equals 2x, or simply y equals 2x. Now, I don't want that whole line. I just want a chunk of it. What chunks do I want? I want 2x, y equals 2x, if x is less than 0. I only want values of x less than 0. Well, here's 0 right here. Should I take this upper portion of the line or this lower portion of the line? Well, here's where x is going to be negative, and that's where x is going to be less than 0. So I don't want this upper portion of the line. I do want the lower portion. Now, it is less than up there, not less than or equal to, so I'm going to put a little circle there. It's open. That's not really part of the graph. It's where it starts. So that's y equals 2x. Now the next part, f of x equals this x, negative x plus 1. We'll put right here, y equals negative x plus 1. That's the linear equation we want to graph. I can see right here that my y-intercept is 1, and my slope is negative 1. That's negative 1 over positive 1. So I'd go down 1 over a positive 1. A lot of people see negative, they go down and back. That's incorrect. So down 1 over 1. Down 1 over 1. Down 1 and over 1. So on and so forth. Or up 1 and back 1. So here's my line of y equals negative x plus 1. I don't want the whole thing. I just want a piece of it. Remember, we're talking about a piecewise function. We're graphing 2 or more chunks of linear equations. I only want this line when x is greater than or equal to 0. So here's 0 right here where x is equal to 0. Y is actually equal to 1 at that point. Do I want the positive part of it or the negative part of it? Well, if I want x is greater than or equal to 0, I want the positive part. So I'm going to take this piece. We'll get rid of this little part right there. It is greater than or equal to, so that's the closed-in end of the line. That's a piecewise function. Notice in this case, there's 2 pieces to my piecewise function, 2 little parts of each of those lines. Okay? Piecewise function. Here we go. This one I can recognize. What is this? Okay. It's absolute value. Whenever I graph an absolute value function, I know I'm going to have some kind of a v. Basically, if I can find my vertex, I should be able to graph this in nicely. Easiest way to do it is plug in some values. Some people go 3 to negative 3. I'm going to go negative 2, negative 1, 0, 1, and 2. And plug in those points and see if I can go down or go up, basically find that bottom point. So if I plug negative 2 in, negative 2 plus 1, the absolute value of that, plus 2. Negative 2 plus 1 is negative 1 plus 2. The absolute value of negative 1 is positive 1 plus 2. This is equal to 3. So when I plug in negative 2, I get positive 3. Let's try another one. Let's plug in negative 1. Negative 1 plus 1. Well, that's 0. Absolute value of 0 plus 2, that's just 2. Negative 1, 2. I'm still going down. When I plug in 0, 0 plus 1, well, that's the absolute value of 0. Absolute value of 0 is 0. 0 plus 2 is 2. I have made a mistake here somewhere. When I plug in -2, I get -1. That's 3. When I plug in -1, I get 0. Oh, I know what I did. 0 plus 1 is 1. The absolute value of 1 is 1. 1 plus 2 is 3. So this is actually 3 right here. Sorry about that. Even I make mistakes. So 0, 3. I can see right there that I have a V. I got my bottom point vertex right there. I can just go up here, up here. I've graphed my absolute value. I'm done. You can still plug in 1 and plug in 2 and graph them. You can see that those points are going to be right here and right here. And it's still part of my absolute value function. Absolute value functions are pretty easy to recognize. If you see a V, it's an absolute value function. So you can look at the graph itself. You can look at the function. If you see absolute value, it's easy. It's an absolute value function. Okay. This is a piecewise function. I can recognize that just by looking at it because of this. You see this little brace or bracket, and there's 2 parts to it. X minus 4 and the 1. F of x is going to be equal to both of those. I have to graph both those lines, but I only want a piece of each one. So I'm going to do this first one. I'm going to look at, remember f of x is the same as y. Y equals x minus 4. We'll get to the if x is less than 2 in a little bit here. Slope-intercept form, y equals mx plus b form. There's my y-intercept, -1, 2, 3, 4. And my slope, well, it's 1x, so that's 1 over 1, up 1 over 1, up 1 over 1. And it just kind of continues on like that. Or you can go down 1 and back 1, just the opposite. So here's my line. Now, do I want the whole thing? No. I just want a piece of this line. I only want the values of this line where x is less than 2. Well, here is 1, 2. Here's where x equals 2. This point right here. Now, anything going to the left would be less than 2. Anything going to the right would be greater than 2. We want less than 2, so we're going to eliminate this part of the line. It is less than, so at 2, we're just going to have an open-ended circle there. That means that point is not part of the graph, but that's kind of where it starts. So there's the first part of our piecewise function. The next part is the 1 right here, y equals 1. Well, there's no variable. There's no x that it's equal to. So this is what we call a constant function when it's just equal to one number. If you're going to put this in slope-intercept form, it'd be y equals a 0x plus 1. My y-intercept is 1. My slope is 0. So basically, it's just a horizontal line. That's the constant function. That's how it works. So we only want this when x is greater than or equal to 2. Well, there's 2 right there. The values going to the right are going to be greater than 2. So I'm going to get rid of this up to that point right there. Put that back in there. Being it's greater than or equal to, it's filled in. That point is actually part of the graph. And that's your piecewise function. Graph the 2 different parts and erase the part that you don't want. I'm going to let you guys try this one. So you're going to try this. I'm going to put the answer up in a second. So you'd hit pause, try this problem, and then hit play again. I'll have the answer up there for you. And if you don't get it right, you can ask somebody in your group or you can come and talk to me. Okay, go ahead and pause. Okay, just unpause it because I'm assuming you're done. This is going to look like, if I do this right, something like that. And something like that. There's your piecewise function. And we're done. Peace out, Girl Scout.